Hi. This is a crash course on Java. I'm using C++ to compare because in Champlain College we teach C++ in intro and advanced programming classes. So everybody knows C++, but we don't teach Java. This is just a crash course. And there are several parts in this presentation, in this inheritance, polymorphism, and continuous. And I would like to create 10-15 minutes each, different videos. Let's start our first part. These are the things: inheritance, polymorphism, interface. We'll be going compile runtime dependencies. What is this concept? And UML class diagram. We will be learning unified modeling language, and I'll be using Eclipse IDE at the end. I will have JUnit testing framework I will introduce and make a simple introduction. How can we step into JUnit unit test? So this is the code we will be going over, and let's study a little bit this one. If you look at, we have a class keyword. This means employee is a class, and this is opening curly bracket, and this is the closing one. Everything else is inside this curly brackets. It's not outside. So we have each variable we define. We put this private or public, or what is the access level. So name, salary, and higher day. We have our parameters, and these are the types of it. And this is a constructor, as you know, which has the same class name that returns nothing, and takes these parameters over here, and we set to our variables, and also create a this local date one with a given year, month, day. So that's it. And we have one getters, and raise salary takes a percentage, and you get the how much is going to effective salaries. But if it's like a 10% of your salary, so you will add to the plus equal to and to the salary. That's it. This is simple studying of the code. So this is the logo I'm going to use. This is C++ information. This means generally in C++ you can have the function inside your class or outside. If it is outside, you use the scope resolution operator to say this function belongs to this class. So it's the class name. Like if you take the class names like a last name, this is the function name. This is within this family last name. Okay. So this makes the if it is here, every C++ code will be inline if it is within the class declaration. If it is outside, that is different. But in Java, it doesn't make everything becomes inline function. No, because JIT compiler, just-in-time compiler, and if the methods are short, commonly called, and not overridden, and optimizes them away. So what does that mean is another subject of this. What is inline function? Let me give brief introduction. If a function is frequently called, you don't want to, if this one is calling, you don't want to go and call and come back. This will take time. So you want to move the copy of the function bytecode here, so it will be so fast calling and coming back. But if it is, this will increase the, what is that footprint of your program, because if you are copying this code several places, its performance will increase, but also the footprint also increase. But if this function is rarely used and you don't want them to copy it, so you make in this case outside of your class. So if anybody needs, just calls it and then comes back to its place, but it's not frequently called. Anyway, so the problem statement is this: we have a company which has managers and employees. There is no other types. So managers are just like employees in many respects, and both managers and as employees paid by salary. But the only thing is, managers get bonuses on top of their salary. So moving on. So how do you proceed to design this within the given scenario? So the scenario, I want to open this Eclipse and then create a new project for us quickly. I'll try to be fast. And which is I'm going to call HR software we are going to do. Next. And finish all of them. I pick the default, whatever it is. I have no source code available. I open the source code, initial source code I just showed you, and I'm going to copy all of them and paste over here, Control V, so it will create employee Java for me. Here it is. All of them, whatever we see on the slide, it is here. A little bit more getters here. We have extra. And there's an inheritance folder just opened. Why? What is this? Is a package. So if you're confused what is package, just giving you brief information on that. If I open this code with System Explorer and it is opened in the other screen, here it is. So if I go to the source folder, this HR, we just created, this is the source folder. And there's an inherit. This is just actually a folder in Windows Explorer, but in Java, it is called package, so we can organize our classes files clearly. So moving back to here, how do you proceed to design this within the given scenario? So what does that mean? We would like to add to our, this is the current existing code, we would like to add and manager. Manager will have name, salary, hourly, but on top of it, it will have bonus. So in this case, it looks like it's is a relationship, right? Is a relationship. Why? Because manager is an employee. So why did we use inheritance? Because we'd like to retain some of what we have already programmed in the employee class, and the fields to original class can be preserved, right? So this is obvious is a relationship. So in plain English, you need to test this. Manager is an employee, isn't it? If this is true, this means you can make inheritance. So this is the hallmark of inheritance is a relationship. But in this design, it lends itself, it's okay for now, but actually in the real world, we don't want to do this because employee can become manager, but objects cannot change its state, right? So we need to use different things. Actually, we need to use strategy design pattern, but this is later on. We will use polymorphism and other things, but let's focus on now currently inheritance. So how do we show in a UML class diagram, unified modeling languages? So these boxes are representing each class. Currently we have employee. We are going to have manager. We use this arrow, means manager is, the arrow direction is important, is an employee. So this is just our UML class diagram. We are inheriting everything from employee to the manager. So C++ note again, and in inheritance in C++, we use colon to define, but in Java we use extends keyword. It's more verbose and it's more clearly readable for human. This can be given different job in different places in C++. It is a little bit encrypted. All inheritance in Java is public inheritance. In C++, we have private and protected. But yeah, that's it. So we would like to try to implement it. This one. Let me bring also the manager for us. Code. I just copy it and go back to here and just copy and paste what we have manager. So let me move the manager to the side, drag and drop here. We can make this full screen so we can see entire stuff. So manager is an employee. Extends means extending the employee. Whatever we have over here, like as if we copied and pasted over here. So manager have all of them. It can access all public functions. Of course, constructor is public and other function, but these are private. So this means it cannot access it. In order to access it should be protected, or do we need to access? We need to make sure, because opening making this privileges lower, it may cause some problem. People, other user, client in the main function can change this one, which is maybe not desired. So in this one, let's look at the manager constructor. Like this is a constructor, right? Because it has the same name. It takes the same number of parameters, and it doesn't take any bonus because bonus default is 0, but you can later on set the bonus the amount you want. And get salary is different. If you look at get salary, returns plain salary in employee, but in this one we add bonus amount to here. That's it. So let's move on to the question I'm going to ask you. So let's see, if you have a manager object, you can simply apply set bonus method. Yes, we can call set bonus method easily, right, with this one. Sorry. So of course, if you have an employee object, you cannot apply the setBonus method. It is not among the methods defined in the employee class. If you go back to here, we don't have setBonus function in employee class. So there is no object, there's no function. So how can I call this one? That makes sense. Move on. So the question is this: in manager class, why don't this code doesn't work? And override, we will go about this annotations later on. But let's say we have a get salary. We are going to override it in this one, because let's get salary. We are not happy with this because it doesn't have bonus part in it. So when I do this salary plus bonus, it doesn't work. If I want to try get salary from, because this salary it doesn't work, I try to this one, also still won't work. Why is the reason? Let's think about it. So the first reason could be the salary, right? Salary is, if it is function, it is function. Let's try to write quickly that function for us and then try to make sure this is working or not. Okay, so here we are, and we would like to override this function, right? I can put override. Okay, and which function to override? Get salary, right? Where is it? Get salary. Okay, get salary function. Right, this is not helping me. Okay, then I'm gonna copy this one. Get salary. It is giving us a problem. Let's see what I'm missing. Oh no, I don't want to do that. I am sorry. I didn't see that function we already have here. So here it is, right? I cannot write that. So get salary, but this is currently working. Okay, I give you the answer already. So this is not working. Let's go back to here because salary is private in here, salary function. So I cannot directly access in here. Secondly, if I call get salary, it will recursively call the get salary of mine, which is, if I say this is its class manager, and I say directly get salary, it will call this one. But in Java, we have a solution for that super keyword. Super means call the base classes function. So when I say super.getSalary, it automatically will call this function here. That's it. This is the answer for that, and it will work fine. So super and this keyword is not, analogous to this reference in C++. Super is not a reference to an object. So, for example, you cannot assign the value super to another object variable. Instead, super is a keyword that directs the compiler to invoke a superclass method. Okie dokie. Moving on. C++, Java uses keyword super to call superclass method. In C++, we use again scope resolution operator to base classes function. So if I want to from manager to call get salary function in the employee, I will use this fully qualified name get salary function I'm going to call, but which is in employee, which is your base class. But in Java, it is different. Super dot get salary, we can directly call these functions. Of course, this function missing open close parentheses, but this is just showing how can we call that. So super keyword, also you need to, for example, all these parameters in the base class we need to pass because all of them are in the base class, right? Here it is. So in order to call that, we call super over here again. This will call the base class constructor. So we pass all these private member variables in order to set, because we cannot set, there is no setters, and we cannot access even though we are inheriting because it is private. This will be the first line in the constructor to call, so you cannot swap these two. So later initialization, if you want to do after the super, you can do that. So must be the first statement, the constructor for the superclass. So private classes are private, so you cannot have access. In C++, note, if you want to call the base class constructor, you have to use again this column. before this curly bracket, after the closing parameter, closing function parameters. This is constructor. So you give the base class's name. In C++, you can have multiple inheritance. So this could be different. So I am passing not with the variable, string, just passing the variable, not without the type. Look at name. I don't say string name. I get actually these variables over here, their year, month, and day, all of them, and pass here. So the employee can set all of them. That's good. So let's create one main function and move on from there. So if I am going to create one main function over here for the test, so if I create a bus, for example, like this var is like auto in Java in C++, so the type will be automatically manager. So I can call set bonus. But if I create an employee like this, I cannot call set bonus, right? Because it is different. So going back to the slide, when this E refers to an employee object, the call getSalary calls the getSalary method of the employee. And if it refers to manager, we will call the getSalary of this one, getSalary of either employee, or let's move this guy down. So our managers getSalary if it is type that one. The virtual machine knows about the actual type of the object to which E refers and therefore can invoke the correct method. Okay, how about this polymorphism? We will come there, but in here, let's look at this code a little bit more detail before moving to, where is the code? Here it is. Oops. Give me a second. Okay. Discard. So where is our Eclipse? There we go. So this Eclipse is here. If you look at this bus, is bus type, which is manager, and employee. This stuff 012. I need to spend a little bit time over here, right? What is this stuff? Is an array of objects, but these are not pointing to anything. But when we use a new, it can point. So this you can see in C++ terms. You can think these are pointers, but we don't have stars over here. They are pointers actually. We are saying this object refers to bus. This object refers to employee. So when I run this code, we will see this the first one is Carl Cracker over here. The salary is this much because we add the bonus also. And these are employee Harry and Tommy. If you look at over here, their salary is the same one what we assigned. So if we are using for each loop over here, and when we call a got salary, automatically calls either the salary of manager or salary of employee. So that's all. How about next time we will go over the polymorphism and we will learn more about it. Thank you.